Okay, so here we'll be looking at connected particles. Many of the concepts are the same as you saw in your first year, except we'll now be working on inclined planes. So we have two particles, P and Q, P being on the inclined plane and Q hanging over the edge. The two of them are connected over a small, smooth pulley by a light, inextensible string. Since it's a light, inextensible string, both particles are moving at the same velocity. Both particles have the same acceleration. Also, the two tensions in the string will be the same. So let's add some forces. We definitely know that weight is acting on both of them, the 10G and the 5G. I've decided the positive direction is up the slope since the 10G is heavier than the 5G, so I've made that assumption for now. We'll add some tension. The tension moves away from the particles. And this one on the slope, since it was a rough slope, does have some friction. The coefficient of friction being 0.2. So let's get on the reaction force as usual and the components of the weight. All right, so we do not know the angle, but we know that tan alpha equals 3/4. So familiar with this now. Sine alpha is 3/5 and cosine alpha is 4/5. Let's get a diagram so you know where those numbers are coming from. And that'll be 4/5 for cosine alpha. Okay, so label these components. 5G cosine alpha, which we know is 4/5, and 5G sine alpha, which we know is 3/5. Okay, diagram's just about fully labeled up. Let's see what we can draw from this. So thinking about particle P, resolving perpendicular, we can calculate the reaction force. 5G times 4/5 gives us 4G for the reaction force. If we go parallel to the plane, we're really looking at F equals ma. So the forces are the tension in the positive direction, the friction in the negative direction, and the parallel component of the weight in the negative direction. All of that should equal 5a. Okay, some tidying up and rearranging. We get T minus 3.8G equals 5a. Moving on to Q, there's only really one way to resolve. So vertically, F equals ma. 10G is in the positive direction, so 10G minus T equals 10a. Okay, these two expressions both have the same acceleration and the same tension. They are simultaneous equations, so we can go ahead and resolve them. Let's add them together. When we add them together, the t's cancel out, which is nice. And we're left with 6.2g being equal to 15a. Some rearranging to get the acceleration, 4.05 meters per second squared. Okay, and the second bit of the question asks for us to find out what T is. What is the actual tension in the string? Well, I'm just going to choose one of the particles to consider and substitute the acceleration into the expression for that particle. So in number 2, which was for Q, 10G minus T equals 10A. 10G minus T equals 10 times 4.05. And making T the subject here, and punching this into the calculator, we get 57.5 newtons for the tension in the strings.